Okay, students, what we are going to do right now is we're looking at distance on a grid, and that really means Pythagorean theorem with our whole a squared plus b squared equals c squared. But probably more useful is where we say that distance c is equal to the square root of a squared plus b squared. What we're also going to be trying to understand is this idea of simple versions of the square roots or simple versions of the slope steps that make those Pythagorean theorem right triangles. Let's take a look at our first one just to kind of open up this idea. If I want to find a diagonal distance here, I can make a right triangle or like a rectangle around this, and that will help me find what the vertical and horizontal measurements are. Let's use a different color to make it stand out some. So we have this sort of pink color here. My vertical distance is 3, and my horizontal distance is 1, 2, 3, 4, 4. So this diagonal distance then would be 3 squared plus 4 squared inside of a square root, or 9 plus 16 inside the square root, which is square root of 25. So I could put down here square root of 25, but square root of 25 simplifies. Square root of 25 is 5. So a simplified square root is when you can rewrite the number with fewer things inside of the square root. That's one version of it. Let's take a look at another version. Okay, for this one, we have a vertical distance of 1 and a horizontal distance that goes 4 on the left, 1 on the right. So that's 5 overall. Now, there's no way to simplify that slope step. If I think of this slope as like a negative 1/5, I can't simplify that fraction anymore. So that's the simplest version. What that also means is I can go ahead and calculate this distance with a 1 squared plus 5 squared inside the square root. So that's 1 plus 25, or 26 inside the square root. And that's the simplest version that we would have for that one. Okay, now let's see something interesting. I noticed that this is a slope of 2 vertical and 8 horizontal. Let's see if I can bring that back. There we go. Oh, try again. Let's see, third time's the charm. So 8 horizontal here. So I have this like slope of 2 over 8, but that could simplify to a smaller slope of, not smaller, but it could simplify to a slope step of 1 over 4. What that means is that I could instead go 1 and 4, 1 and 4. So I could think of the triangle that has a vertical of 1 and a horizontal of 4 and just do it twice. And that gets me the same length there. Well, for one of these, that would have been the square root of 1 squared plus 4 squared, or square root of 17. But I have 2 of them, so I'd have square root of 17 plus another square root of 17, or the simpler way to think of it is I have 2 of them. I have square root of 17 and square root of 17. That makes 2 times the square root of 17, because I have 2 of them. Now I could have done this where I did square root of 2 squared plus 8 squared and thought of that as 4 plus 64, which would have given me 68. And then 68 is the same as 4 times 17, which is, I could simplify a square root of 4 as 2 square root of 17. This, to me, is harder because it requires a lot of numerical mental math, finding factors that have to be squares that could simplify. Instead, I'm going to see if I can find simple slope steps and then see how many of those simple slope steps that I would use. Okay, let's repeat. Well, here we go. We have a 3 vertical, 1 horizontal. So that's as simple as it can get. There's no way to break that down into simpler steps. So I would just have 3 squared plus 1 squared, or 9 plus 1, which is square root of 10. So that's the simplest version of that slope. Here, it almost looks like I might have something that could simplify for the slope step. I notice that on my grid, I hit a couple of points on the grid on that diagonal line perfectly. So let's see what happens if I make slope steps hit to those points. So these are going to be repeated slope steps of vertical 3 and horizontal 2. Vertical 3 and horizontal 2. Vertical 3 and horizontal 2. So I have 3 of these. And to find this Pythagorean theorem, it would be 3 squared plus 2 squared, or 9 plus 4, which is 13. But I have 3 of them. I got square root of 13 plus square root of 13 plus square root of 13, which makes 3 times the square root of 13. Excellent. Okay, now we have one. It looks big, but it's hard to tell if I can simplify these slope steps. So let's see what they would come out to. I have a vertical distance of 7 and a horizontal distance of 4. And if I thought of that as a fraction as 7 over 4, that's not a fraction that has simpler slope steps. So I would just have to find that total distance as a full step, 7 squared and 4 squared. So we're going to have 49 plus 16, and that's going to give me 65. So 65 is our simplest version of that slope. For these next ones, we need to draw the line ourselves, but then complete the same process that we had been doing. So if I see 3, 1, and 6, 0, that's a nice, small, simple triangle. With a 1 and a 3. So we'll have a 1, a 3 for my simple triangle here. That's going to be a 1 squared plus 3 squared. We saw this earlier, 1 plus 9, square root of 10. And that's the simpler version of that number. Let's see what happens in our next pair of points. We have 6, 3, and negative 4, negative 2. So 6, 3 is here. And then negative 4, negative 2 is pretty far away. It's hard for me to maybe draw perfectly straight lines. So I'm going to start with my big step, look at that fraction, and then try to determine how would I break it down into smaller steps. So this has a rise of 5 and a run of 4 and 6, which makes 10. So I have a 5 over 10 slope. but that could be equal to steps of 1 over 2 or 1/2. So I'm going to go 1 over 2, 1 over 2, up 1 over 2, up 1 over 2, and up 1 over 2. And it looks like I have 1, 2, 3, 4, 5 of those. So this little triangle of 1 and 2 for the legs is going to have square root of 1 squared plus 2 squared for the hypotenuse. Well, that would be a square root of 5. So I'll have square root of 5 plus 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 square root of 5. That means I have 5 of those square root of 5 steps. 5 square root of 5. Now we have 2 points at 0, 1. So 0, 1 is on that vertical axis, and -4, -3. Now when I look at this one, I can see it's a nice 45-degree angle here. And those 45-degree angles have convenient slope steps of 1 and 1. So I have a 1 and 1, 1 and 1, 1 and 1, 1 and 1. I have it 4 times there. And this little triangle with a slope step of 1 and 1 is just 1 squared plus 1 squared, or square root of 2. So I have square root of 2 4 times, or 4 times the square root of 2. If I had done this the long way, I would have done a full step of 4 vertical and a full step of 4 horizontal. So that's telling me that I could have done 4 squared plus 4 squared, or 16 plus 16, which is square root of 32. Okay. Let's finish with just these last few. We have -1, -5, 3, 3, and that looks like vertical goes 8, and horizontal goes 4 for the lengths, which I have a feeling that's going to break down to something simpler. So we can do 2 vertical and 1 horizontal, and we should arrive at the same length. And it looks like we do it 4 times. Well, let's figure out what this diagonal length of a 2 vertical and 1 horizontal would have been. So that's a square root of 2 squared plus 1 squared, or square root of 4 plus 1 is 5. So I have square root of 5, square root of 5, square root of 5, square root of 5, 4 times. So we have 4 times the square root of 5. Excellent. Now we have a 3, 3, and a 6, 1. What do you know? Now we have an already simple step because it's just a 2 and a 3, and that cannot get simpler. That's the simplest version of that slope. So that would mean I have 4 plus 9, or square root of 13. Square root of 13 cannot simplify. Now for our final one, we go to 3, -2, and -3, -5. Ooh, this one could do something. We have a vertical of 3 and a horizontal of 6, and 3 over 6 could be simpler steps of 1/2. So 1/2, 1/2, 1/2. And I have 3 of those. And I believe we've done this one before. 1 squared plus 2 squared, for this 1/2 slope is going to have a distance of square root of 5. And we have it in here, square root of 5, square root of 5, square root of 5, 3 times. So that'll give me 3 times the square root of 5. Okay, this was repetitive, but it was intentionally repetitive to get used to this idea of taking a full slope and seeing if it can simplify into smaller steps. And sometimes it can, but sometimes it can't, and it's already simplified, which means that your square root won't have any number multiplied on the outside as a simpler version. That's it for this video. Thanks for joining, and go back and check it again if you missed anything in the middle.